The last topic in this section is on the effective rate of interest. This is also referred to as the annual percentage yield. The annual rate of interest, this is the annual rate of interest that when compounded annually will yield the same accumulated amount as the nominal rate compounded m times a year. Okay, so this is when we're working with compound interest. Maybe we're working with two different accounts, with two different rates, two different compounds, and we're trying to compare the two to see which one has the better rate. Well, we can work with their effective rate of interest, so that way we can compare the two, right? If we can compare the two's effective rates of interest, then we can see which one's better. All right, so this allows us to compare the interest rates, even with different compounds. All right, so this is how we do it. Okay, so here we have the compound interest after 1 year compounded annually. Okay, that's what the effective rate of interest is. That's the interest amount after 1 year, assuming that it's compounded annually. And that's A equal P times 1 plus R over M raised to the M times T, right? But we're saying after 1 year, so T is 1. And we're compounding annually, so M is 1. All right, so that just simplifies it to A equal P times 1 plus R. The compound interest after 1 year compounded M times, right, that's the A equal P times 1 plus R over M raised to the M times T, but T is 1, so just raised to the M. Okay, so if we were to take these, right, so we're starting with a problem that gives us the interest rate compounded M times, and we want to convert it to the effective rate of interest. And so we're going back to the definition of effective rate of interest. This is the annual rate of interest that when compounded annually, this one right here, that's the big R, will yield the same accumulated amount as the nominal rate. Nominal rate is what we've been working with previously, compounded M times a year, right? So we want these to be the same. Right? We want these to be the same, right? So we've got the effective rate of interest formula, and we've got the regular compound interest formula, and we're saying that we want it to yield the same amount. In other words, we want these two A's to be equal. So we're going to set these two equal to each other and solve for capital R to get the effective rate. All right, so let's see how that is going to look on the next slide. All right, here we've set those two equal to each other. P times 1 plus R equals P times 1 plus R over M to the M. And we're going to go through the process of solving for R. So to solve for R, we need to get R by itself. So dividing both sides by P, right, cancels the P on both sides. That gives us 1 plus R equals 1 plus R over M to the M. And then to solve for R, subtract 1 from both sides. And now we've gotten R by itself. R equals 1 plus R over M to the M minus 1. So this is the effective rate of interest. If we know the nominal rate of interest, that's the interest rate that's given, and we know the number of compounds per year, then we can find the effective rate of interest. Once we find that effective rate of interest, we can use that to compare two different investments to see which one's better. For example, find the effective rate of interest for the Fleet Street Savings Bank, which pays 4.25% interest compounded weekly, and for the Washington Bank, which pays 4.125% compounded daily. All right, so and then we can compare which one's better, which one has a better investment. Is it better to invest your money in 4.25% compounded weekly, or 4.125% compounded daily. And it's not so obvious here. Now, if you were to just look at the rates, of course, 4.25 is better than 4.125, but Washington Bank has more compounds, right? You're compounding daily, 365 times a year, as opposed to only compounding weekly, 52 times a year with the Fleet Street Savings Bank. So it's not so clear cut. You have to take into account the compounds. But we can calculate the effective rate of interest for each of these banks, and then we can compare the two. All right, so for the Fleet Street, what is the effective rate of interest? So we're going to say that R is 1 plus the interest rate of Fleet Street Savings, 4.25 or 0.0425, divided by compounded weekly, M is 52, minus 1. Okay, I'm going to set up the formula for Washington as well. R is equal to 1 plus 0.04125 divided by compounded daily, 365 days in a year. Some places you'll see that they use 360 instead. We're going to use the traditional 365 days in a year for compounded daily. All right, once we have that formula set up, then we can use the calculator for to simplify these calculations. So we've got 1 plus 0.0425 divided by 52 raised to the 52 minus 1. That gives us the fleet effective rate of interest. And while we're on the calculator, we can go ahead and do the Washington Bank. 1 plus 0.04125 divided by 365 raised to the 365 minus 1. Okay, so now let's look at our effective rates of interest here. Let me write that down. So for the Fleet Street, that effective interest rate, the annual percentage yield, is 0.04338 or 4.34%. And for the Washington Bank, we've got 0.042110. Which is 4.21%. And so these effective rates of interest, now we can compare these two numbers, right? These are on the same playing field, right? So we can compare these two and know which one is the better investment. And here we can easily see that the Fleet Street Savings Bank gives us a better rate of return, that effective rate of interest, the annual percentage yield for the Fleet Street is higher. So if we're trying to decide which one to invest in, the Fleet Street Savings Bank is the one to go with. It edges slightly over the Washington Bank.